Hey guys, this is Fernando Notari, and this lesson would be on inverse functions. So before we begin, I just want to draw attention to something real quick. This right here is inverse function notation. So it basically reads f inverse of x, the negative one just indicating inverse. Right. So now that that's out of the way, what is an inverse function? So an inverse function basically undoes all the mathematical operations of another. So if that's the case, if you plug in 5 into a function and get 10 out of it, you should be able to plug in 10 into its inverse function and get 5 out of it. So let's test this out real quick with this example. So f of x equals x squared plus 3, and f inverse of x equals the square root of x minus 3. So let's try plugging in 5 into the original equation. If we plug in 5 into f of x, we get x squared plus 3, therefore 28. And if you plug in 28, or the output, into its inverse function, we get the square root of 28 minus 3. The square root of 28 minus 3 is equal to the square root of 25, or 5. Alright, so how do you solve for the inverse of a function? So in order to solve for the inverse, you have to switch the x and y variables and isolate y. So for example, if y equals x plus 8, you have to switch the x and y variables such that x equals y plus 8 and isolate y. So you move over the 8 such that y equals x minus 8. Therefore, f inverse of x equals x minus 8. So that example is pretty straightforward. Let's try making another one just to make sure that you guys get it. Given that y equals, let's say, 3x plus 4. Let's solve for the inverse of this. So in order to solve for the inverse, the first thing we do is that we switch the x and y variables such that x equals 3y plus 4 and isolate y. So what we do here is that we have to first move over the 4 and then divide by 3. So as an end result, we would have y equals x minus 4 divided by 3. And that would be our inverse function. So I'm sorry, let's never forget to put the negative 1 in here, indicating that it is the inverse. So that is our inverse function right here. Right. So how does this look graphically? So given the same example that we had on the previous slide, y equals x plus 8 and y inverse equals x minus 8, we would have these two lines right here. The red line indicating the original function and the blue line indicating the inverse function right here. So as you can see, the functions are reflected on this dashed line, and this dashed line is actually y equals x right here. So whenever you have an inverse function, whenever you take the inverse of a function, the graph of the inverse will be the same as the graph of the original function, except that it is reflected on this y equals x line. All right. So let's get another example here, but this one's a little bit more complicated. So the red line represents the function y equals x squared plus 3, and the blue line represents its inverse, or y equals square root of x minus 3. As you can see here, both functions are still they're still reflected on this y equals x line. However, this function, the blue line, is missing. You have a part of it missing. You can see that the parabola is not actually complete. We're missing a part of it. We're missing half of it actually. So this is a case because, as we know from previous lessons, each function can only have one output for every input. And here, if we plug in 5 into this equation, we would actually get two answers. We would get a point that is right here, but also we would have a point that is around right here. And that can't be the case. So what we do is that we limit the range of the inverse to make sure that it is still a function. Otherwise, this wouldn't be a function, and we wouldn't need the graphical representation after all. So, lastly, we're going to go over how to test if two functions are inverses or not. So we can do this by a composition of functions. So what this means is that both f of f inverse of x and f inverse of f of x must be equal to x. So I know this sounds a little bit complicated, all this function notation, but it essentially means that if you plug in f of x into f inverse of x, you should get x as an answer. Not negative x, not 2x, just x. So let's just do an example real quick to make sure that everybody understands this. Okay, so let's say we have the function f of x equals x squared plus 5, and f of x equals the square root of x minus 5, and we want to check if they're inverses or not. So what we do is that let's say we want to, let's do this one first. First, let's do f of f inverse of x. And it doesn't really matter the order that you guys do this in, just as long as you do it in some order. Nobody's gonna really care. So let's assume that, let's first plug in the square root function into the square function, into the quadratic function, sorry. So you would have here, you'd have the square root of x minus 5, which is one of the functions, right? Squared plus 5. So now let's solve for that. You get, if you square this, you're gonna end up getting just x minus 5, because the square root and the exponent are gonna cancel out. So you're gonna get x minus 5 plus 5. Forgive me for my handwriting in here. It's hard to write on a computer. So you know that these two 5s are gonna cancel. They're gonna add up to 0, and our answer would be x. So we're good for now. They could be inverse functions, but we still have to test it the other way around. So what we do is that you get the square root of the original function, right? So it would be x squared plus 5 make sure you have the parentheses right, and then minus 5. So the parentheses here don't really matter. This is just to indicate that this was the first, that this right here was the first function. So from that, we're gonna get x squared. We're gonna get the square root of x squared, because the 5s are gonna add up to 0 again. So then we know that the square root is gonna cancel out the exponent, and again, we're gonna get x as an answer. So therefore, we know that these two functions, f of x equals x squared plus 5, and f of x equals the square root of x minus 5, are inverse functions. So that is it. I hope you guys learned something, and I'll see you guys at the next lesson.